Think math.
A third is nought point 333 running on without end. But suppose you have to write that value down. 100 threes is not the end. 1,000 threes is not the end either. We need a way to write something endless, exactly, on a finite piece of paper. The way in is the repetition itself. As we saw last time, a repeating decimal is some block of digits recurring word for word. So write that block once and add a mark saying it goes on. Writing infinite information finitely is only possible by writing the repeat down a single time. But the mark cannot go just anywhere. Put a single dot somewhere on nought point 123, and the reader cannot tell whether the 3 repeats, or the 23, or the whole 123. Those are 3 completely different values. A notation that can be read as several values has failed as a convention. So we pin down both ends. A dot goes over the first digit of the repeating block and another over the last, and everything between them is the block. If the block is a single digit, its first and last are the same digit, so only one dot appears. The rule has not changed. The 2 dots have merely landed on top of each other. With that convention, you can run it backwards. Lift out the block between the dots, repeat it along the tail, and the original decimal comes back exactly. One finite piece of notation now names exactly one infinite decimal. That is the job those 2 dots do. So the dots are not decoration. They are boundary markers. They pin down where the repeating block starts and stops, so one notation names one value and no other. Next time, how long that block is allowed to get. See you in the next one. A sip of math every day here at Think Math.